Hello everyone, my name is Nilesh. In this video tutorial, I'm going to discuss the make command and makefile. I consider you are C++ developer looking forward to compile your application more effectively and efficiently. The make command is most popularly used to build the C applications having hundreds of source code files. In this video tutorial, we will start with absolute basics like what is make, why we have makefile. We will write some very basic makefile, and then we will progress to reasonably complex makefile. After learning this video, you will be able to write your own makefile. You will be able to read someone else's makefile, and you should be in a position to update the makefiles of some reasonably good projects. So let us get started. Before I continue onto this, let us talk about one scenario where we have a C program with multiple files like main.c, product.c, product.h, and I want to compile and execute that particular application. How exactly the compilation and execution is carried out? In my previous video, I discussed how to compile and execute the single file program. And there we discuss the detailed steps, including preprocessor, compiler, assembler, linker, and so on. However, when we are developing multi-file projects and our day-to-day development, we do not need to implement all these steps. Rather, we only talk about the most important stages, compiling each .c file into .o, and then you create the final executable by combining all these object codes with the library. So let me take you to the practical example. Here you see that I have implemented such simple application. You can take a quick look at the code where we are accepting product structure and displaying it back. And in main, we are simply calling these functions. If I want to compile this, I have two .c file, so I need to create two object codes separately. How we can do that? GCC -c main.c. This will create main.o. GCC -c product.c. This will create the product.o. And then you will call linker to linker both of them together. And let's say output file name is app.out. In Linux, particularly, you do not need any extension for the executable file. I'm going to consider the app.out file over here. And let me give the input product.o and main.o. And here you see that app.out is built successfully. You can quickly run this application where you can enter some product detail and you find that this application is working perfectly. However, now the next question is, if at all I modify some of the file, if I go back to the file, let's say product.c, and I try to do certain changes in this file. Now you tell me which files I need to really modify. In this case, do I need to modify all the files? Answer is no. In this case, only product.c is modified. So ideally, you should recompile only product.c. This will create new product.out, and that is the reason you need to also rebuild the final executable app.out, and it was dependent on product.o and main.o. Now you have your application ready. You can again enter the details and you can find that things are working well. This is very easy for such a small application. But what if I have such hundreds of files, and then keeping track of exactly which files are modified, and only recompiling those files and then recreating the executable file, this is going to be really complicated. And that is exactly the reason why the make command exists. Over here, we do not want to manually figure out which files we need to recompile. Using the make file, we are going to build a dependency graph. The dependency graph, which is explaining that main.c is compiled into main.o and product.c is compiled into product.o. And then both of them are combined together to create app.out. In our application, we have also written product.h and we have included product.h in both of them. It means that if I modified main.c, I need to only rebuild these files. And if I modify product.c, I need to rebuild these files. While if I modify this product.h, then I need to recompile all these files and then my executable will be ready. But as I was saying, make is going to do this particular job automatically for you. So how we create this dependency graph? We create this dependency graph in a file called as a Makefile. The Makefile contains the set of rules. What exactly the rule is? The rule is basically telling which file you want to create, and it depends on which file. It is called the prerequisite or dependency. And to create the target file using prerequisites, which command to be used? It is also called as a recipe. You can see the example. The example below, you have app.out. It is dependent on main.o and product.o. And to build app.out from these two, you need to use a command like this. Similarly, to create main.o from main.c, you need to have this command. Likewise, the product.o depends on product.c and you can give this command for that. Something very important syntax that I want to highlight. In this particular rule, the first line, it is representing dependencies. Second line is representing command. And you can see that this command is always given followed by a tag. The make is very particular about this syntax. It must be a single tag. Number of 4 or 8 spaces are not acceptable over here. You must give the tag, and after that you need to give the make command or recipe over there. Let us go ahead and implement our very first Makefile. In this particular case, I will create a Makefile and I'm giving a name as Makefile with M capital. By the way, if you are making a Makefile, you can also give the other names. The most preferred name is Makefile with M capital. You can also give another name called as a Makefile, everything in small case. Or one more name can be given is GNU Makefile. If you want, you can even give a custom Makefile and you can use it with the make command -f flag. However, the most popular is nothing but the Makefile with M capital. That is the reason we are going to use that name throughout this particular tutorial. Now, in this tutorial, we want to build total 3 files. One is app.out, second one is product.o, and another is main.o. The basic rule is that the final file that you want to create should be written at first. That is the reason I have started with app.out. This is my final executable and it is dependent on product.o and main.o. Now, to create app.out, the command is gcc -o app.out, and we can give the input as product.o and main.o. But this product.o itself is dependent on product.c and product.h. To create product.o, the command will be gcc-c product.c. Please note that in this particular case, we are suggesting that if either product.c or product.h is modified, the product.o has to be recompiled. And same thing, we are doing it for the main file as well. So I have dependency main.c and product.h. I will give gcc -c main.c. That's it. It is very simple way to write a Makefile. I repeat the syntax. The first line is representing the dependencies. The target colon depends on which file, the prerequisite files. Second line, very importantly, the tab has to be given, and followed by that the command which will create the target file. And these multiple rules are separated by the empty lines written over here. Now let me save this file and just give a very simple make a command. If I give the make command, it will create the .o file and .out file. I guess we already compiled it once. So let me do one thing. Let me first delete the existing .o and .out files. And now I will say make. Have you seen that? Over here, we have created product.o, main.o and app.out. You can run the application and you can confirm the output. So this is very easy. Now, specialty of the make. The specialty of the make is if I modify any of these files, any small change done in a file. Now, the make is smart enough to understand that main.c is modified after creation of main.o. So next time, if I give the command like make, what it is doing? It is only recompiling the main.c and then rebuilding the app.out. If I do the changes in product.h, now what will happen? In this particular case, product.h is used in main.c as well as product.c. So ultimately, it will compile all files and rebuild the executable file. Let us consider one special situation. What if I have not modified a single file and I just used the make command? Now my application is just built, it is working, and I have not done any change into any of the source file. In that case, you will see that it will simply say that app.out is up to date. There is no commands to be executed to rebuild that file. So you understand how exactly make work. First of all, it will find the requested target, and the default requested target is a first target in the file. For our case, it was app.out. Then it will check its prerequisite. The prerequisites are probably product.o and main.o. It will also check the timestamps. So are product.o, main.o, are they newer? Or if they are not created, then they themselves are dependent on which files? Product.c, main.c. Are those files are modified? It will be checked. And then if required, the only modified files are recompiled, and then final dependent target will be rebuilt. This is how the make command works. It makes your process highly efficient. You may not realize the actual use of the make command in such a small project, but the real world projects have literally thousands of files, and compilation process itself might take some minutes to even hours. At that time, if the files are already compiled, if there are no changes into those files, then recompiling the same file again and again is wasting that much of time. This is where the smartness of Make come into picture. The Make will only recompile and rebuild those files which needs to be compiled, where the corresponding source code files are modified, and that can speed up your compilation process in from minutes to sometimes seconds as well. Now that you have understood how exactly Make works, it's time to write the Make files in a more professional manner. In the previous application, you've seen that I created a Makefile, I hard-coded GCC. I might need some sort of a compiler flags. If at all I need the compiler flag, I need to go and modify the compiler flag in every GCC command. The compiler flag can be some optimization flag, it can be some debugging flag, or it can be some other flags as per your requirement. Instead of rewriting these flags into every command, it will be good idea that we will try to write it once globally and we will use it at the other places. This is more or less like macros in C language. That concept is called as the make variables, and declaring make variables is very simple. Let us go ahead and start creating more professional Makefile. Before that, let me just delete the existing .out files, and purposefully I'll retain this version so that you can refer this later on from my GitHub repository. Let me create another copy of this C program, cp-r v1 underscore C program v2 underscore C program. Let us go into this and let us make our Makefile more professional step by step. First of all, I will declare the compiler. Let's say cc is equal to gcc. You can also mention C compiler flags. Those flags can be optimization flag, maybe no optimization, maybe warning flags, or if you want to give any additional flag as per your requirement, feel free to add them over here. You might also need some linker flag, especially when you are dealing with the libraries at that time. For time being, I'm just keeping it simple. Now, compiler flags, I want to use it for compilation commands like this C flags. Compilation flags, I'm using it over here, C flags. And then compilation flag, I will also use it over here, C flags. And at this place, I will also use the linker flags. Please note the syntax. I need to use dollar, and within parentheses, I need to give the name of the make variable. Similarly, for GCC, we will use cc in all these commands. Now, let us go back and try to make. Have you noted that the changes are applicable in all the commands? If I wish, I can go and modify the flags. Let's say I removed the warning flag, and automatically it will be available on all these files. Let us take a look at this make, and you see that hyphen warning all is removed from all of them. These are just the basic user defined variables, but the real power is into the make's built-in variable. Make comes with plenty of built-in variables like dollar caret, dollar at the rate, dollar less than. What exactly these variables mean? Let me tell you quickly. You can take a look at $@. The $@ in each command is representing the corresponding target. So at this command, the target is product.o. In this command, the target is main.o. And in the earlier command, the target is app.out. So in general, $@ is representing the current target. Second, we have $less than. $less than represents the first dependency or first prerequisite. You may have the multiple prerequisites like main.c, product.h, but $less than is only the first dependency. Something similar is for product.c. Finally, we have $caret. This $caret is considering all the prerequisites. So if you have given 1 to 10, all those prerequisites will be considered into $caret. Please note, $less than is the first prerequisite, while $caret is all prerequisites. Let us try to implement it in our Makefile. Let me not modify in the same Makefile. Instead of that, I'll prefer to create a copy of this. So let me again create a copy like V2 C program as V3 C program. And let us get into this. Let us start modifying the Makefile. As I was saying, wherever we have like a name of the output file, we can simply write $@. So you need not to write app.out. As far as .c file to .o file conversion is there, the compiler automatically give the name of .o file same as .c file. So product.o will be created from the product.c. However, if you want to explicitly specify the name, you can give that by writing -o $@. You can give the name -o and $@. Next, here we have multiple dependencies, main.c and product.h. Which dependency we are using to create main.o? Only the first dependency, that is main.c. That will be written using $less than. Similarly, we will use $less than over here to represent first dependency product.c. And over here, I do not need only the first dependency. I need all .o files which are given in prerequisites. So I should use $caret over here. That's it. These are special make variables. Let us go ahead, use make command, and you will see that our application.out file is built successfully. Here I talked about a simple example of the make variables and makes built-in variable. But I would like to take you to one more example where we will try to understand about the assignment operations. In the previous example, we have used only equal to, but you can also use colon equal to or question mark equal to or plus equal to. How exactly these signs are used? Because as you go onto the more professional makefiles, there are likely chances that you will come across these signs. Let me explain you with one simple example. So here I have declared one makefile. This is very simple makefile and it is not even used for compilation. It is only to test the makefile syntax, where we have declared two make variables. The first variable is greet equal to hello, and the second variable is user, where I'm saying equal to $greet, comma Nilesh. But have you noticed that on the next line, I have actually modified the value of the grid. Then in this particular make, there is a single target, which is test target, and I have written one echo statement. The first question is, what is the @ sign over here? The @ sign ensure that the command is executed without printing command on the screen. So you will only see the output on the screen, not the actual command having @. Because by default, whenever the command is written, it will first display the command and then execute that command. Over here, only the command is executed, not displayed on the screen. Let us see if my grid is modified, what exactly the result that we get it over here. So I'm just making it make. And have you noted that the earlier value of this grid was hello? The later on value is modified to high. Now when I'm executing the Makefile, at this point, whatever is the latest value of the grid is considered, that is nothing but the high. So I can say that this particular equal to sign is a lazy evaluation. Meaning by, in this particular case, this $grid Nilesh message came over here, and then this grid is handled, the grid is evaluated at runtime, not immediately on this line. It is evaluated on this line. This evaluation is called as a lazy evaluation, or it is called as a recursive evaluation. Now I'll do a little change in this file and I'll use the colon. Now see the effect of colon equal to. Now when I say make, it is showing me the result hello Nilesh. Why it is so? Because in this particular case, colon equal to is immediate evaluation. So at this line, whatever is available value of grid, that value is evaluated, which is hello, comma Nilesh, and that will be assigned to the user. Later on, even though you are modifying the grid, it will not impact the evaluations done above that. And that is the reason when this user is printed, you see the output as a hello Nilesh. You will find that this colon equal to is also used at plenty of places. I've seen them very frequently into the Linux kernel or device driver Makefiles. Let us continue further. There is one more interesting part. We also have something called as a question mark. So question mark hello. This is called as a conditional assignment. What is the meaning of conditional assignment? If grid variable is not having the value given previously, then and only then consider the hello. In this particular example, at the moment, since we are not giving any value, you will find that the value is taken as it is. Let me declare one environment variable. I can declare it in Linux using export command. So export, the name of the variable is grid is equal to, I'm saying namaste. Done. And now I'm giving the same make command once again. Do you see the output is namaste English? Why it work like this? Because of environment variable, grid is already assigned to namaste. When the make command executed and execution came to this line, it seemed that grid already have the value namaste from the environment variable. So it didn't recreate or reassign that particular variable. It just reused the existing value and continued further. This assignment is discarded. Not only environment variable is a way to give the input, but we can also use make command line arguments. So I can give make, I can write grid equal to, let's say I'm writing namaskar. Now you see the output is namaskar Nilesh. Again, same way, in this particular case, the grid was already given the value namaskar. That value is used and this particular assignment is discarded. That is the reason you get the output as namaskar Nilesh. These three are most seen assignment operation. One is normal equal to, another is colon equal to, another is question mark equal to. This will help you to read the professional Makefiles easily. Apart from that, there is also plus equal to. The plus equal to is very straightforward one because plus equal to is just appending it to it. So if already I have, let's say, user, I can simply use user plus equal to, and already Nilesh is been written. Let me append something else. And in this particular case, you see the output is the environment variable followed by Nilesh and Gule is appended to that. So plus equal to, you can use it for appending to any existing environment variable, which is very popularly used for the names of your source code files, which is also used for adding more flags into your C compiler or linker flags. Now that you have understood the make variables, make built-in variables, you understood the different syntax. Now it's time that we can go ahead and we can talk about C++ Makefile. Since compilation process of C and C++ program is same, the actual Makefile is almost similar. You need to follow exactly same syntax. What changes is a few things. Number one, you traditionally use the different make variable instead of CC, CXX to represent the C++ compiler. Similarly, instead of C flags, we use CXX flags. Now this is more of matter of convention that you use it. And what obvious change is instead of .c file, you will have .cpp files. Let us go ahead and see this practically. So let me take you to another folder where we have v1 cpp program. Here I have already created main.c, product.cpp and product.h. You will see that over here, instead of struct, we have used classes. Instead of rewriting the whole Makefile once again, I'll prefer to copy the existing Makefile. How? Let me use cp and existing Makefile. We have, let's say, v3 cpro Makefile. Let us modify that next file. Over here, instead of cc, we will use cxx g++. Instead of c flags, we will use cxx flags, and instead of .c files, we will give .cpp files. Let me also update the occurrences of these variables into the Makefile, and then we are ready to go. Program is compiled and output is going to remain similar. If we can give some product and we can give some price, everything is going absolutely well. So here you see that we have built the application executable once again. Let me clean up this and talk about another problem that we would like to see in this application. As you have built the simple C++ application, now the question is, what if the new classes are created, new .h and .cpp files are added? Consider the case, if I have, let's say, book class, I have new book.h, book.cpp created. In this particular case, what you will do, I have simply added one extra rule over here. It is okay to add one particular rule for one new file. But what if you keep adding such new classes? Every time keep adding these rules, don't you think it will be overwhelming. And that is the reason we have a new concept called as a pattern rule. Instead of writing rule for a specific file, we can write the rule for the pattern, where we are saying that any .o file is dependent on corresponding .cpp file, where percent is a wildcard. Can we write our Makefile like that? Let us go back and consider the situation over here. Instead of writing the whole Makefile once again, let me copy the Makefile from the previous program. Makefile copied into this. Instead of adding the new rules, let me first of all remove the existing rule. And then I will have one common rule for compiling all .cpp file. Instead of giving the name of each .cpp file separately, I'll give the name %.o depends on %.cpp. And then you simply add the names of the files that you need it over here, like book.o, tape.o, whatever files that are available. Compile this and you will find that your application is compiled. In future, if you are adding one more file, let's say I'm creating one simple file, let's say touch test.cpp, and I want to add this particular file into my code. What I can do to build that file? Only one small change to be done. Just go back to the Makefile and add one thing extra. Simply say test.o over here. Moment you do that, your Make is smart enough to understand that test.o is dependent on test.cpp and it will take care of recompiling it. Let us take a look at it. I just say make and you see that all the files are compiled, including this test.cpp file. This is so easy. Though it is so easy, still I don't find it very readable. Why it is not that readable? Because I need to keep adding at a particular line. Instead of adding at a particular line, can we think of having a make variable and make it more effective? Answer is yes. Let us consider that instead of putting all the files over here, let me declare some additional make variables. One of the make variable that I'll declare is a target. Let me give the name app.out. And let me have another make variable which is indicating the names of my .cpp file. The first file is main.cpp. You can continue adding the name over here like product.cpp, book.cpp, tape.cpp, or you can make effective use of plus equal to operator in order to make it more readable. Now I can say that book.cpp, I can add tape.cpp. In future, I can add test.cpp or any other file that you want to add. The plus equal to is practically useful in this scenario. Now the question is what I want to write over here. I want to specify the target, and this particular target will be dependent on all the .o files. The problem is I have sources file .cpp. What I need over here is objects file. What exactly I can do for this? For that, we can do the make substitution. Take a look at, we can write objects is equal to, and I can mention over here, this objects is equal to sources, but in this sources, wherever .cpp is written, that has to be replaced with .o. So currently my sources is main.cpp, product.cpp, book.cpp, tape.cpp, test.cpp. Every .cpp will be replaced by .o, and then you will see that objects will be main.o, product.o, book.o, tape.o, and test.o. Now I can simply use objects over here. That's it. This is compiling as per my requirement. If you want to add a new file or you want to remove a file, let's say for example, I want to remove this test.cpp. What will happen? I need to again go back into my Makefile and I just simply remove this test.cpp from here. And automatically you will see that the make command compilation will be reflecting it accordingly. Let me do make, and you see that the test.cpp is no more compiled. I'm sure you find this particular feature really useful. Now it's time to talk about another more interesting feature. The more interesting feature is, you must have noticed that every time to delete a particular file, I was writing rm star o star and giving such kind of tedious command. Don't you think that to rebuild a project, it is very common requirement to clean the project? Some of the time you might have a requirement that you want to execute your application using the make command itself. If you want these additional commands to be supported into your make, what you can do? You can add the special rules for them. So what special rules? Let me show you one rule over here. One rule that I want to add over here is a clean rule, which is very commonly used by many people, and where I can specifically mention rm forcefully delete the target and also delete all object files. That's it. Now I just go back and make it. To clean it, I need to only execute make clean, enter. Now I need not to give the rm command manually. So whatever object files and executable files are created, they get deleted very well over here. Going one step ahead, I can also add some more rules over here. Like one of the rule, I can use it for executing the application, where I can mention run. I know that my application can be executed as simple as /app.out, or if you do not want to hard code, you can mention the name target over here. And to run this, I can simply use, let's say, make run. And you see that your application will be able to execute. Let me first make it and then make a run. My application is ready, where you can enter, let's say, book. I have book one, the price, something. I want to give some pages, and you see the result. Everything is working perfectly. Going one step ahead, what if my compilation process becomes a bit more readable, clean, well formatted? For that, I will add one more target over there. Suppose that I'm adding a target, something called as a begin, where I'm just putting a message, let's say echo, and I just say that it is building application. Done. I can make one more, let's say end, where I'm mentioning that application is built. And now I'm expecting that the output should be the combination first begin, all compilation process, and at the end. Will it be working like this? Yes, you can do that by putting one more target on this. And usually such target is written at the start with the name called as a all. The all target, where I'm saying that you build the target. But before the target, you mark begin and you also mark the end. Now what will happen? Whenever I'll give the make command, by default, the first target is all. It will see that the all is dependent on begin. So it will first execute the begin command. Then it will come and try to build the target file app.out. For that, the entire compilation process will be carried out, and afterwards it will see end. Then it will also execute this end rule. Let us take a look at if it is working well. Let me first clean the existing one, and now I'm saying only make. Have you noticed the first begin, then my whole compilation process, and then the end? This can make your make more interactive. You can give the cleaner messages. But at this place, I have written so many additional targets. The additional targets like the clean target, run target, begin target, end target, all target. You ever thought of what will happen if there is some file in your project with the name clean, or in your project with the name begin or end? Don't you think it would be kind of confusing? Yes, it can be. So it would be wiser that you explicitly tell the make that these are not the names of files. These are nothing but the pseudo targets. These are just the virtual targets, not the real files to be created. And how I can inform this to the make? I can inform this to make by writing a special rule that is called as a .phony. .phony, and you mention the name of all such targets like all, clean, run, begin, end. You can write them in any sequence. This is only to tell the Makefile that these are not the names of files, rather these are the imaginary targets, these are the pseudo targets, right? Now that our Makefile is reasonably good, let me show you another interesting feature. The interesting feature where instead of you adding the source code files into our Makefile manually, we can try to auto detect it. That is referred as dynamic source discovery. For that, the Make has got a special keyword called as a wildcard, and then I can mention wildcard star.cpp. Will it work? Let us give it a try. Instead of doing the changes into this demo, let us create a new copy. And for that, I will use cp-r. We will have v2 cpp program. I'll create a copy as v3 cpp program. Let us get into this v3 cpp program, and inside this, let us modify that Makefile. Over here, instead of writing sources explicitly, let us mention sources is equal to dollar, within parentheses, I have, let's say, wildcard keyword, and you mention star.cpp. Currently, everything is into the same directory, so I'm not giving any folder name explicitly. Now, let us go ahead and try to do the make once again. Have you noticed? It has taken care of compiling all .cpp file. And now the magic is, if I add another new file, let's say touch test.cpp, without even opening a Makefile, if I try to compile it once again, you will see that it has automatically compiled it. That was the magic of that wildcard. It has automatically selected all .cpp files in that particular folder, and corresponding object list is created. It has compiled all the object files and also created the final executable. I hope this is amazing. What all we learned in this video? We started with the manual compilation, and we understood why you need the make. Then we understood the basic syntax, how to write the rules in the Makefile, specifically target, colon prerequisite. On the next line, tab followed by the recipe or the command. Then we understand the dependency graph. The make file is creating a dependency graph and the make command is going to execute the necessary command to build the target, especially when the files are modified. Then we talked about the variables like cc, cflags or cxx, and we also talked about different assignments like equal to, colon equal to, plus equal to. We've seen the automatic variables like $@target, $caret, all prerequisites, $less than is first prerequisite. We've seen how to create a C++ makefile. It was just matter of changing the compiler, file extensions. Then we talked about the general pattern rule, how to create a .o file from corresponding .cpp file. We also discussed the phony targets or virtual target so that their names are not conflicting with the existing actual file names. Then we talk about dynamic source discovery by using wildcard and substitution pattern like .cpp is equal to .o. And then we came up with the final makefile. I hope you found this particular video useful. Let me know if you are interested in knowing some special features of the makefile or some concepts of C++ into the comments. I'll try to make my next video on this. Thank you very much. See you in the next session. Bye bye.